This is Chapter 12, Exercise number 2. We're going to be calculating lead time. And it says Michigan Machining Company machines metal parts for the automotive industry. Under the traditional manufacturing approach, the parts are machined through two processes, milling and finishing. Parts are produced in batch sizes of 50. A part requires 4 minutes in milling and 9 minutes in finishing. The move time between the two operations, batch, is 10 minutes. Under the JIT philosophy, the part is produced in a cell that includes both the milling and finishing operation. The operating time is unchanged. However, the batch size is reduced to 6 parts and the move time is eliminated. Determine the value-added and non-value-added total lead time and the value-added ratio under the traditional and JIT, just-in-time manufacturing methods. If required, round it to the nearest decimal place. Keep in mind that as we are doing this, we are going to consider the value-added versus non-value-added. Value-added time is the time which the customer would be willing to pay for. Non-value-added time is something the customer doesn't care to have because they don't feel it's required. For instance, such things as rework are things which are non-value-added. Customers don't want you to have to rework it. They want it right the first time. Just as warranty. While they want a warranty to have confidence that it'll be done, they really don't want to have to take it in for warranty work. It's a bother. So those are considered things as non-value-added. In this case, we're going to be looking at the production time, and we're looking, therefore, the lead time or throughput time. We have a milling, which is 4 minutes. We have milling, which is 4 minutes. We also have finishing, which is 9 minutes. So our total time then, which is value added, is the 4 and the 9, or 13 minutes, which is value added. Okay? Now we have a batch size. The batch size in this case was 50 units. When we're working on that 1 unit, the other 49 units of that batch are sitting and waiting. So we're not adding any value to those units while they're waiting. So we have 49 units waiting while we're working, so I can multiply this times the 49, and I can calculate my non-value added time associated with it. So I'll take 13 times 49, and that looks like 637. So I have 637 of wait time. In addition to that, I have 10 minutes for that transfer between the movement time between the two units. So I can add 10 minutes to this number, and I get 647 as my non-value added traditional under the traditional philosophy. And of course we determined that we had 13 minutes under the value added under the traditional method. So my total lead time, I can add these together, the 13 plus the 647, and I get 660 as my total lead time. I can now calculate, if I take the 13 divided by 660, the percentage then is 0.01969 . Well, I can round that off, and that would be 0.02. So we'd have 2%. That's how I calculate that percentage there. Now let's look at the JIT method. Under the JIT method, we still have the same value added time and the batch processing time doesn't change. However, we do have a change in that we have our batch size is 6 minutes or 6 parts, and our move time is eliminated. So those are significant. So in that case, my wait time, the units of the batch, are going to be the 6 units minus the one that's being worked on, or 5 which are waiting while I'm working on that one. So my non-value added time is 5 times 13, which is 65. So I have 65 minutes. My move time is 0, so that's been eliminated. So my total non-value added time is 65. My value added time is still 13. My total between these two, if I add them together, is 78. So 13 plus 65 is 78 minutes. That's my total lead time. I can then make the calculation as a percentage of value added time to the total lead time. That's going to be 13 divided by 78. That equals 0.166666667, or rounding that is going to be 16.7%.